quite wordy, this one. The numbers below are represented in floating point, 5-bit mantissa in 2's complement, and a 4-bit exponent in 2's complement. Normalise the numbers and show you're working. Right, okay, so I'm going to write out that number with a binary point for my purposes. So 0.0011. Right, the exponent is currently, let's see if I can read this one properly, is positive. And that is actually 2. Yeah, I've got that right this time, haven't I? So it's currently 2. Now, to normalise it, we're looking for the final sign bit. So all the duplicates we want to ignore. So that's a duplicate sign bit. That's a duplicate sign bit. That's the last sign bit. That's where I need to move the binary point. Now this time I'm going to go right. So I'm going to go 1, 2. So I've gone right. So I've actually made this number larger. So that gives me an exponent of -2. It was originally +2. So what does that make the overall exponent? 0. So overall, the exponent is 0. And just so I make it easy, I'm going to write the word 0. So the format for that was 4 bits. So I'm going to write out the exponent. So it was 0, 0, 0, 0. Right, I'm going to write this out neat now. So that is my sign bit. Then I've got 2 1s. But I was told this was a 5-bit format. So I need to pad on the right hand side with some empty bits. And that's my mantissa. Okay. Final one. Same job at... Whoops. That didn't seem logical to me. I don't know why. Right. Final one. We've got negative number. Same old process. I'm going to start with that exponent though. So the exponent this time is positive. So let's write a plus. It is a 4 and a 2. So that's +6. Right. I'm going to write this out so I can do the transformation with the binary point movement clearer. So we've got 1 1 0 0. Right, look for those duplicate sign bits. So that's a duplicate, that's a duplicate, that's the final sign bit. So that's where I'm going to move. So 1 2. Okay, so I've made this number larger, so that gives me an exponent of -2. But originally it was 6. So what does that make the overall exponent? 4. So the overall exponent is 4 plus 4. In 4 bits, that's going to be 0 1 0 0. So that's my exponent. And my mantissa is going to be 1 0 0. But obviously I need to pad it with some zeros. So that's my mantissa. Always an odd looking mantissa when you get that. With a negative. It just looks weird. It's like there's no detail to it. It's about clarity. And it's about checking. So if I start with a negative number, the mantissa still needs to be negative. Any questions about that one? Right.